For this video, I will present the normal distribution. The normal distribution is the most widely known and used of all distribution. Notation for normal distribution is n, mu, and variance. For the mean is mu, variance is sigma square. Probability density function is 1 over square root of 2 pi variance exponential negative x minus mu square over 2 variance. This example for normal distribution, the manufacturer of a soda fuel cans with an average value 12.1 and knows that the machinery has a standard deviation of 0.15 if it assumes that the distribution of liquid in the cans that are filled from a bell-shaped curve, that is the normal distribution, then what percentage of soda cans are underfilled in the there is supposed to be 12 per a can. The mu is 12.1, sigma is the standard deviation equals 0.15, the value of x is 12. So we plug in the value of this formula, z equal observed value minus mean over standard deviation, or x minus mu over sigma. So we will get the negative 0.67. So we check in normal distribution table, we will get 0.2514. The percentage of soda cans is 25.14%. Second example is, in an exam, it is not that the distribution of marks is normally distributed. Mu equal 51 and sigma equal 3.5. What proportion marks more than 48? So we plug in into the formula x minus mu over sigma. The value of x is 48 and mu is 51 over 3.5. We will get negative 0.86. So we will check in table normal distribution. The probability of x more than 48 equals 0.4443. The proportion marks is 0.4443. Example 3 is the score of reference population on the WISC. The mu equal to 100 and the variance equal to 15. Find a range of WISC scores which contain 95% of all WISC scores for population. So we will use empirical rules so that 58% of observation fall between 1 sigma of mu. So the value is between 85 to 115. 95% of observation fall between 2 sigma of mu. So the value is 25 to 130. 95% of all scores fall between 75 and 130.
Hi, today I would like to explain about binomial distribution. Binomial distribution is one of the discrete probability distribution. It is used when there are two outcomes, like the success or failure. Okay, this is the binomial distribution notation, where n stands for number of trials and p stands for probability of success. To find mean for binomial distribution, we just simply times n with p, where n, as I mentioned earlier, number of trials, and p is probability of success. For the variance, n times p times 1 minus p. PMF, probability mass function for binomial distribution, is nk times p power of k times 1 minus p power of n minus k, where k is the number of successes. For MGF, moment generating function, is 1 minus p plus p e power of t, the whole thing power of n. Thank you. Example 1. A coin is tossed 3 times. Find the probability of getting 2 heads. N equals to 3, P is equal to half. You plug into this formula, where px is equal to n factorial over n minus x factorial times x factorial times p power of x q power of n minus x. Probability of 2h equals to 3 factorials divided by 3 minus 2 factorials times 2 factorials times the average half power of 2 half power of 1 is equal to 0.375. So the probability of getting 2h is equal to 0.375. For a second example, if a student randomly guesses at 5 multiple choice questions, find the probability that the students get exactly 3 correct. Each question has 5 possible choices. N is equal to 5, x equals to 3, and p is equal to 1 over 5. We plug into this formula. Probability of 3 is equal to 5 factorial over with 5 minus 3 factorials times with 3 factorials times with 1 over 5 power of 3 and 4 over 5 power of 2. It is equal to 0.05. So the probability of each student gets exactly 3 correct is 0.05. Third example, a survey from Teenage Research Unlimited found that 30% of teenage consumers receive their spending money from part-time jobs. If 5 teenagers are selected at random, find the probability that at least 3 of them will have part-time jobs. N equals to 5, P is equals to 0.3, Q equals to 0.7. Then we plug into this formula. P3 we get 0.132. As for P4 equals to 0.028. P5 equals to 0.02. Then for P, at least 3 teenagers have part-time jobs equals to 0.132 plus 0.028 plus 0.002 equals to 0.162. Thank you.
Hi, I would like to talk about beta distribution. This is the PDF for beta distribution. The PDF for beta distribution is equals to 1 over b alpha beta times with x to the power of alpha minus 1 times with 1 minus x to the power of beta minus 1. The mean for beta distribution is alpha over alpha plus beta. The variance for a beta distribution is alpha times beta over alpha plus beta squared times with alpha plus beta plus 1. The first scenario is during the late 50s when the US Navy was working on the Polaris nuclear submarine project. The Navy's Special Projects Office developed a beta distribution tool called the Program Evaluation and Review Technique to manage the thousands of tasks and estimates that were required for the complex project. The PERT measured 3 values for time estimates, cost estimates, and work effort estimates. These values were categorized as optimistic, most likely, and pessimistic times. The second example for beta distribution is to solve this equation y equals to x over 1 minus x. The first step is to let gy be the probability density of y. So, x will be equal to y over 1 plus y. Okay, then we need to differentiate the y equation up here. And the answer for the differentiation is 1 over 1 minus x squared. So, gy will equal to fx times with the modulus of dx over dy. And that will equal to 1 over b pq times with y over 1 plus y to the power of p minus 1 times with 1 minus y over 1 plus y to the power of q minus 1 times with 1 minus y over 1 plus y to the power of 2. The answer will be fx equals to 1 over b pq times with y to the power of p minus 1 over 1 plus y to the power of p plus q with the limit 0 to infinity. Okay, the third example, the question is, A utilities industry consultant predicts a cutback in the Canadian utilities industry during 2010 to 2015 by a percentage specified by a beta distribution with beta equals to 0.25. Calculate the probability that Ontario Hydro will downsize by between 10% and 30% during the given 5-year period. Okay, this is the solution for this question. First, fx equals to beta plus 1 times with beta plus 2 times x to the power of beta times 1 minus x. That will be 2.8125 times x to the power of 0.25 times 1 minus x. Okay, thus we must find the probability x between 0.1 to 0.3. We must integrate the value we found before, we get before this one. Okay, we integrate from 0.1 to 0.3. Then we will get the answer 0.2967. So, there is approximately a 30% chance that Ontario Hydro will downsize by between 10% and 30%.